कंप्यूटिंग पता है? Why we use this term computing?
Calculation.
Yeah, process or functions. Some procedures are there or functions are there that will take some input and it will process it and generate some output, right? This is computing. यही है ना? By the help of some function or procedures generating an output based on some input, it is called computing. तो उसमें क्या होता है, एक फंक्शन रहता है कि सपोज अगर मैं न्यूमेरिकल तो पढ़े हो, उसमें उसका एक फंक्शन अगर बोले तो y इज इक्वल टू एफ एक्स है ना, एक कंप्यूटिंग फंक्शन है। ये फंक्शन क्या कर रहा है, कुछ इनपुट्स को ले रहा है, कुछ इनपुट्स को लेके उसमें कुछ प्रोसेस करके एक आउटपुट जनरेट कर रहा है। जो इनपुट्स ले रहा है वो होता है एंटीसीडेंट और जो आउटपुट जनरेट होता है वो होता है कंसिक्वेंट। ठीक है, कंप्यूटिंग का यही प्रोसेस है। तो इसका कंप्यूटिंग का कैरेक्टरिस्टिक्स क्या क्या है, इसका मतलब कंप्यूटिंग का कैरेक्टरिस्टिक्स है, एक तुम्हें सॉल्यूशन दे रहा है, राइट। ये सॉल्यूशन जो है प्रिसाइज सॉल्यूशन भी हो सकता है, अनप्रिसाइज सॉल्यूशन भी हो सकता है, इम्प्रिसाइज भी हो सकता है, राइट। दैट मीन्स a computing will always give you a solution, right? If the algorithm is right, if the algorithm is right, then it will always give you a solution, and it follows some steps. That means some algorithms are there. For algorithm, for any algorithm, you have to follow multiple steps. So some accurate steps will be there, right? That steps will be followed by the function. Okay, and it will follow ambiguous or unambiguous steps. Now, another characteristics of this computing is the main characteristics of this computing is it is following some algorithms, right? So always there will be an algorithm to achieve some results or conclusion. These are some characteristics of computing. Okay, now this computing is basically of two types. Okay, the first computing type that was introduced by Zadeh, L.A. Zadeh. Okay, it was conventional type computing. That means which type of programs we are doing, or you are doing since second year or first year. Normal programming, you are doing some programming, writing an algorithm, or doing some programming that will generate some output. These are conventional computing. That means in conventional computing, first I'll tell you what is conventional computing. As of now, it is very necessary, very important to know that conventional computing and soft computing and the difference between these two. So this conventional computing is also known as hard computing. So hard computing and soft computing, we have to differentiate between these two. Okay, so conventional computing, or also known as hard computing, it is nothing but some computational process that will give you a precise result. Okay, that will give you a precise result with unambiguous steps. Some unambiguous steps will be there to solve the problem. That means there will be an algorithm that will have some unambiguous steps, and these steps will generate a precise result. See, in numerical, don't think about numerical. Some other problems, simple calculator. You are making a calculator where you are performing an addition function is there. So this addition function is taking inputs. Some values are there. These inputs are some values. These values are given by the user to the system, and that system will process it and generate a summation or the result. and this result is precise result. This result is precise result. Okay, every time if you give the same input, it will generate the same output, right? 2 plus 3 is 5. Output will be 5, and 3 plus 2 output will be 5. Every time the output will be same. This is that is the precise result will be there, and this result um, precision. There is a precision in the result, and the input that you are giving, that is also an precise input. That we know that these numbers, we know the numbers 3, 2, these numbers we know that. But if I say we don't know the numbers, the number can be 1 to 5, any numbers between this 1 to 5 range. Then there is 1, 2, 3, 4, 5. Only these 5 numbers? No. Infinite numbers are there. That is imprecise. Right? So in that case, hard computing or conventional computing, that it always deals with precise results and unambiguous states for problem solving. The example, I've given you an example, simple example. न्यूमेरिकल प्रॉब्लम्स जो हमने लास्ट सेमेस्टर में सॉल्व किए थे, उसका भी क्या होता है, एक प्रिसाइज रिजल्ट रहता है, तुम्हें पता है एक रिजल्ट आएगा, प्रिसाइज रिजल्ट आएगा, राइट? सर्चिंग एल्गोरिदम जो होता है, सर्चिंग शॉर्टिंग एल्गोरिदम, इसका भी रिजल्ट रहता है, प्रिसाइज रिजल्ट रहता है। शॉर्टेस्ट पाथ एल्गोरिदम जो रहता है, उसका भी रिजल्ट रहता है। तो ये सब होता है एक कन्वेंशनल कंप्यूटिंग और हार्ड कंप्यूटिंग में। ओके, so the difference between this hard computing and the soft computing is, what is soft computing? I'm telling you now. The soft computing is collection of lots of methodologies are there in soft computing. It is a collection of methodologies which is aimed to exploit some imprecision, uncertainty. There is an uncertainty, imprecision, whereas in hard computing the result was precise. Here the result will be imprecise. Any result can be there. You can get any result. Every time you are uh, uh, generating the output, that will be different. Okay, so this is the difference between hard computing and soft computing. And this soft computing, we are dealing with the imprecise result and the uncertainty to achieve. What is our aim? Our aim is to achieve the robustness and low cost solution. So low cost solution and robustness, what does it mean? This robustness means here in soft computing, the inputs may have lots of noisy data, or as well in output. Noisy data can be there. Okay. So this type of noisy data, if we take this noisy data as an input to generate some output, that will obviously generate some imprecise output. Okay, and this technique was developed after conventional computing or hard computing, so we can deal with some these values like which we don't have any idea about this value. This value can be there. I'm giving you a simple example, like we know that 0 and 1, true and false, means false and true, right? But if I say that true is 1, you know that, and false is 0, but If I say 90% of truthness, then what will you denote this? How will you denote this? 0 or 1? 90% of truthness or 70% of truthness. Then how we can denote it? It will be 0 or 1, right? So these types of problems, types of problems we can solve with soft computing techniques. We have lots of soft computing techniques. Lots of soft computing techniques are there, but in syllabus we see three concepts are there. That is, first concept is fuzzy logic. Okay. Second concept is neural network, and the third concept that is probabilistic reasoning, and also known as genetic algorithm. Okay. So this fuzzy logic is based on some fuzzy data. Fuzzy mean vagueness. Okay, some noisy data. We don't know what I gave you some example, that is 0 and 1, false and truth. But in between this 0 and 1, there are lots of numbers, infinites of numbers, right? So based on that numbers, we can say that the truthness or of the some parameters, right? If I say the parameter, some parameters, the truthness of this parameter is 0.4. The value is between 0 and 1, right? 0 and 1. It is not fully false, not fully truth. There is an uncertainty of being false or true. Am I making you confused? So this is the concept of soft computing. This is the concept of fuzzy logic. What I told you, that it is the concept of fuzzy logic based on some parameters, that if this parameter satisfied, and along with this parameter another parameter is satisfied, then an output will be generated. Like in hard computing or conventional computing, if else statement. You did you written some codes uh, in C, C++, and any languages. If else statement is there. If else statement, if this condition is satisfied, then nested if else we can apply, and so on. Right? Fuzzy logic is based on this technique, where we have uncertainty, and the result that will be generated will be imprecise result. Okay. And in artificial neural network, it is basically, see, one thing is there. Our soft computing model, this soft computing, it has a role model that it follows. The role model is human brain. Like how our brain works, computing, the soft computing technique, actually, the aim of the soft computing technique is adapting the human brain nature. In artificial neural network, we'll see that. Okay. As the name suggests, artificial neural network. You are all of you are familiar with AI, artificial intelligence. But before going to AI, there is a term artificial neural network. This neural network, this neural term means neuron, adapting the human brain nature. Then this type of computing is adapting that nature. So the role model of soft computing is basically human brain. So neural network, I'm giving you one example, like teacher student. Okay, this is the best example and common example, teacher and student, right? So how a teacher will teach a student so that the student can learn that topic? How? Multiple ways are there, multiple processes are there. Teacher can provide question and answer to the student. Teacher can ask the question, and student will try to answer it by reading books, right? Excuse me. Okay. So the example I was talking about, teacher and student. Okay. This teacher and student example, in this teacher and student example, teacher can ask question and he can also provide the answer to the student. Teacher can ask question and student can find out the answer from books by reading books and so on. Many probability can be there. We can match these two parameters, teachers and students, giving questions and answer, this types of things. Like a student can learn everything from book. No teacher is required that for that purpose. Okay, so these types of constraints may present there. So this neural network, artificial neural network, works on this learning process. How you are giving your the artificial neurons the message, so that the message of some data, you can say the data, so that that neuron can learn from the data, and in next step or in future step, or you can say it can forecast the output. If in future the same types of data as we feed to the neuron, that means in teacher and student relation, teacher is feeding the student, right? Teacher is feeding the student some topic on some topic and something like that, so that the student can learn. Similarly, what is happening here? This in student is learning from teacher. Here, the user will give the inputs, lots of inputs, lots of big data sets will be created to the network, so that this network can adapt or they can learn from the data, and it can generate output based on the data. Okay, so this is the work we'll see in artificial neural network. So artificial neural network, I told you, and fuzzy logic, I also told you that truthness and false. Another example I can give you for fuzzy logic, that you may notice that when you go to the doctor, doctor will first ask you the symptoms, right? Suppose you have 5 symptoms. Okay, so based on these 5 symptoms, doctor will came to an conclusion that you have this disease, right? Like fever, cough, and so on, these types of symptoms. Then you have COVID. Okay, then doctor will ask you to test COVID, do COVID test, right? So similarly, fuzzy logic, what it does is we have lots of parameters. If this parameter is true and some other parameters, some of these other parameters are true and false, then one conclusion will be there. We have to make permutation combination. So fuzzy logic works on this way. Okay. Then it comes genetic algorithm. Genetic algorithm or probabilistic reasoning is there. Genetic algorithm, in genetic algorithm, what it is? It is basically the genetics parts, that is that we have already studied in higher secondary level, uh, the genetics part, right? So adapting, suppose I'm giving you an example, some technology is there, and this technology is adapted by or this in this generation we are adapting lots of technologies, lots of advanced technologies, right? This adapting nature or this nature, the nature of adapted, we adapt some new things, that is in genetic algorithm. Okay, the best result we will choose. We have lots of algorithms to do a process, particular process, but we will choose the best algorithm, right? So this best algorithm will be selected and it will be carried forward to the next uh, generation by generation. Right? So this is genetic algorithm that we will study. So we'll see some theoretical parts, and in fuzzy logic we'll solve some problems of fuzzy logic. We see everything in this entire course of soft computing. So the first thing that I have discussed today is computing. What is computing? It is not so much important computing, but what is conventional computing and hard computing? You have to know that what is conventional computing or hard computing, and then what is soft computing. The characteristics of hard computing and soft computing. These points are important. Note down. So what are the characteristics of soft computing that I told you? You need to keep in mind in soft computing three terms. Always you need to keep in mind for soft computing three terms. One is uncertainty, imprecision, and robustness. Okay, uncertainty, imprecision, and robustness. Imprecision is main, imprecision and uncertainty, then robustness. Data can have lots of noise. Okay, so the characteristics based on that we can say that if we summarize the concept of soft computing, then it is basically an approach that compute the solution of existing problems. Some existing problems are there where the result has some imprecise things and fuzzy, or that means vagueness in return. And this soft computing has another important characteristic, that is adaptive in nature. The soft computing is adaptive in nature. That means if the environment is changing, the function or the computing process will adapt the entire thing based on the change of nature, and it will generate the output. Okay, so this is another characteristic, that is adaptive in nature. This is the characteristic. So these are the characteristics, and I also have given you some touch of fuzzy logic, artificial neural network, and genetic algorithm. And if I say about genetic algorithm, if an example I did not give you an example that we have lots of banks in nowadays, and based on this bank, which bank will give you more return? Which bank will give you more return? Right. So we can form a model using genetic algorithm, and this algorithm will give you Based on the market and stock market and the current situation, it will give you an idea that this bank will give you more return. So this is an example. Stock market works like that. Is that clear?